Hi, my name is Christos.
And I'm Ace.
My name's Wentong.
And we are students at Purdue University, and our project is enhancing supply chain efficiency with predictive supplier modeling. So, just a background on the business problem. We worked with a corporate partner to acquire our data set, and they wanted us to be able to predict lead times to find the most optimal supplier per part order. So from here, we took our data source that had about 25,000 rows of data. We did the usual cleaning, pre-processing, and here's just a brief overview of that data set. And then we just got some basic descriptive analysis on the initial data set, clustered suppliers based off three factors using a threshold of plus or minus 5 days. And from there, we were able to start building our models.
So basically the point of this project is given a part number and then a supplier, for example, part A from supplier B, we want to know how many days will it be on time or late in a future order. So firstly, we take the historical data. For example, part A was ordered 5 times, and then we put it into our first model, which is the classification model. So we're trying to predict whether this order will be late, on time, or early. And then from there, we put it into another model, a regression model, to see how many days is the order late or early by order, is it on time.
So here comes the result. You can see from here, like the first top two rows is the model we trained based directly from the data itself, not using our two-step model. And the result here is kind of bad compared to our own model. So the biggest improvement for our model is we, instead of directly training the model, we divide them to two parts. First, we classify the data first to see whether it is on time, early, or late, so that we can better capture the pattern within the data, given this pretty noisy data set. And then we use the regression to do the prediction within each class, which greatly improve the accuracy of the prediction. So we can see on average the model itself for the whole data set is 12 days from the actual the prediction is 12 days from the actual delivery days, and for each class the performance of each model is always better than the original model we use. So there's a great implication for the stakeholder that by using our two-step model, they can greatly improve the accuracy of predicting the late times, and also they can identify top suppliers for a specific part, so that they can assign this part to that suppliers to improve the efficiency of the supply chain. So that's be our industry implication for this whole project. Thank you.